Top of the day to you, anytime you're listening to this lecture, and a warm welcome to class. I am Dr. Kuku. Today we're on lecture series 7, and we're going to learn descriptive statistics, particularly measure of central tendency and measure of dispersion. Starting with measure of central tendency, which is also known as measure of location. It is a type of descriptive statistics used to indicate the number at the center in a distribution. It is a good indicator for describing the representative data of any sample. The way of determining the number at the center include the median, the mode, and the mean. Alright, but quickly to correct certain impression we have about measure of central tendency. Measure of central tendency is determining number at the center, using a number to represent the entire distribution that is given to us. It is not synonymous to mean, median, and mode. Mean, median, and mode is only the means of determining the number at the center. So it is a means to an end, not the end in itself. Moving forward, how do we use mode to determine the measure of central tendency? With mode, this refers to the most occurring number in a distribution, that is the number with the highest frequency. It is possible that in a distribution we have two or more tie as most frequently occurring. As a result, such distribution will contain two or more modes. If distribution has two modes, it is referred to as bimodal distribution. However, if it has more than two modes, it is referred to as a multimodal distribution. How do we compute mode? To compute mode, the computation of mode varies when computing for a grouped or ungrouped distribution. The class will be limited to the computation of mode in an ungrouped distribution. However, we'll look at when it is computed with raw data that you can manage, the way the raw data appears, and also the data that can be managed in a frequency distribution table. But the initial experience we'll have here will be based on raw data. Very few data that you can manage without necessarily drawing a frequency or representing them in a frequency distribution table. We have this example here. The following data give the examination score of pupils in numeracy. We have 77, 67, 74, 81, 71, 68, 74, and 73. We have to find the mode. How do we determine the mode? We said mode is the number that occurs most often. So you're looking at these scores here. It may not be out of place. As much as possible to arrange the number chronologically to be easier. But you agree with me that in this data set, only 74 occurred twice, while each of the remaining score occurred only once. Thus, our answer will remain 74 is the mode because it has the highest frequency of 2. Not forgetting, frequency is the number of times the score occurred. So 74 occurred, only 74 occurred more than once. Other questions there we can use to at our leisure to find the mode. And disadvantages of using mode. One of the advantages of using mode is that it can be calculated for both kind of data, whether it is quantitative or qualitative, whereas the median and the mean and the median can be calculated only for quantitative data. For example, we are given the status of 5 students who are members of the student senate at the college. They include senior, sophomore, senior, junior, senior. Find the mode. Easily here we can spot the mode to be senior, because only senior that occurs 3 times when compared to sophomore and junior. So it is easier. This is a kind of qualitative data. It is only mode that can be used to determine the score at the center or the value at the center when it is qualitative. However, when it is quantitative, the the mode can still be used. However, mean and median cannot be used when it is qualitative. But when it's quantitative, all the three can be used. Moving forward, mode is the most used with categorical data and where frequency response is important for describing categorical data. Mode is used with ordinal, interval, and ratio data, which we have looked at in the past. Whichever one can use mode for these categories. However, its usage may be useless when scores or values are not repeated in the distribution. One of the exercises given to us earlier, if you look at them, I think we will see a clear example of such there, whereby all numbers were unique. They were 1, 1, 1. There was no repetition at all. In that case, it is difficult to use mode to determine the number at the center. Though mode is not as popular as other measures of central tendency, it is also not affected by extreme score, or what we call the outlier. Then what do we understand? Values that are very small or very large relative to majority of the values in the data sets are called extreme scores. So when we are having values whereby other scores are not far from themselves, not too far away from themselves, and we have a particular score that is either very large when compared to others or very low when compared to others, these are what we refer to as extreme scores or values. We also refer to them as outlier. Here we'll stop the explanation of mode. We move on. With median, this is the middle number in the data set when data is arranged in order of magnitude. So for us to determine the median, we must arrange chronologically, either ascendingly or descendingly. Let's go through the steps of computing a median. 1. The first thing to do when you see a set of scores given to you and you are to compute a median is to rank the distribution. This can be ascending or descending. From the highest to the lowest remain ascending, and from the lowest to the highest remain descending. Thereafter, determine if the distribution is odd or even. What we mean here is that the total number of scores given to you, when you count them, is it odd or even? If the distribution is odd, there will be one number in the middle. Then this will be the median. What do we mean by odd? Example of odd include 3, 5, 7. These are numbers that are not divisible by 2. So when we have any such distribution that is given to us and it is odd, it is easier to identify the number in the middle. I'll give a small instance here. If you are given a distribution of 5, you are given scores, 5 scores. After arranging chronologically, without looking at the data yet, you should be able to tell me that since it is 5, which position will be in the middle? You agree with me that the position that will be in the middle will be the third one. Similarly, if you are given a distribution of 7, which is also odd, the position that will be in the middle will be the fourth. If you are given 9 in a distribution, the position that will be in the middle will be the fifth position. So any score that falls in the fifth will be the one in the middle, and it will be only one number. However, if the distribution is even, there will be 2 numbers in the middle. When there are 2 numbers in the middle, the 2 numbers that are in the middle will be circled. We will have to add them together, then divide by 2 in order to get the median. Again, if it is even, the distribution is even, there will be 2 numbers in the middle. We have to add those 2 numbers together, then divide by 2 to get the median. A clear example is what given the following data gives the weight loss in pounds by a sample of 5 members of the health club at the end of 2-month membership. We have 10, 5, 19, 8, and 3. Find the median. Also, we have determined the median and the following set of values: 22, 16, 28, 19, 23, 14, 21, 19, 29, 28. So going through the following data, weight and loss. Okay, we talked about that. The first thing to do is to arrange the number either ascendingly or descendingly. That was done here. It was arranged in a descending order. Having done that, since there are 5 scores in the distribution, will you agree with me that if you do any count, either from the back or from the front, we are to spot or to identify the third score? So from here, it is clear that since the count of score is 5, which is odd, only one score will be in the middle, which is the third position. Then the number occupying the third position is our median, and our median here is 8. That's for the first example. Was given the set of scores, again we have to arrange chronologically, ascending or descending. In this case, the count of scores in this value, in this distribution, is 10, which is even, meaning that there will be 2 scores in the middle, which is the 5th and the 6th position. To identify the median, then we have to add these 2 numbers together, then divide by 2, which is 21 plus 22 divided by 2. This gives us 43 divided by 2, and our median is 21.5. With this, we have been able to get the number at the center for this particular distribution. Ease of using the median. Median is less affected by extreme scores or outliers, unlike mean, which is seriously being affected by, greatly being affected by extreme scores or outliers. Median is not affected by extreme scores or outliers. It is usually preferred measure of central tendency when the distribution is not symmetrical. And the limitation that it cannot be identified for nominal or categorical data, we said that earlier, and it is not based on all observation. You just look at positioning to identify the number at the center. Having looked at that, we want to look at by which we can determine the measure of central tendency. The mean is obtained, the mean, which is the next one we want to look at. It is obtained by dividing the sum of all values by the number of the values in the data set. Again, the mean is obtained by dividing the sum of all values by the number of values in the data set. So meaning that we have mean x bar, which is usually denoted by that, the summation of x over n, that's for sample, while for mean population, it's by mu, denoted by mu, sum of x divided by capital N. The small n identifies sample, while the population is identified by the uppercase N identifies the population data. And I hope you can recall the difference between the population and a sample. The earlier formula given to us, which is summation x over n, is usually used for data given to us that is raw, that is not arranged in a frequency distribution table. However, if the data given to us is arranged in a frequency distribution table, the formula we are to use is to find sum of fx all over sum of f. This particular formula will be useful when we have an example of a frequency distribution table. Having said that, let's look at how to compute a mean. The following are the ages of all 8 employers of a small company. We have 53, 32, 61, 27, 39, 49, 44, 49, and 57. Find the mean age of these employees. Similarly, we have another one. You might have to pick one here to do, then you can try that out on your own. 7 babies weigh the following amounts: 2.5 kg, 3.1 kg, 3.4 kg, 3.5 kg, 3.5 kg, 4 kg, and 4.1 kg. Find the mean weight of the babies. We'll do with the first one. Make do with the first one. And the first one here is following the ages that is given to us. How do we determine the mean? First, we have to state the formula, which is sum of x divided by n. Not forgetting that the data given to us here is not in the frequency distribution table. Since it's not in the frequency distribution table, we have the option of the first formula for computing mean to use, which is summation x over n. So here, we are saying that to determine the mean, we have to add all the numbers up and do a count of the scores there, the values there, and divide it by the number of scores in the distribution. The number of scores in the distribution is 8. And we have to add 53 plus 32 plus 61 plus 27 plus 39 plus 44 plus 49 plus 57. This sums give us 362 divided by 8. This shows us that the mean age of the employees in the company is 45.25. That's an example of how to compute the mean. So what are the mean? In mean, it takes into account all values or scores in the data set. That's one big, and the strength of the mean is that it's about the only measure of central tendency that accounts for every scores in the distribution before getting the number at the center. Besides, it can be used in comparison of distribution, especially continuous data. So you can find the mean of your class or different generation in your class, and say you'll be able to make comparison that, oh, so set had the average score of this, while this so set have an average score of this, which can be used also laterally. Maybe there are several arms in a school. You want to know the average performance of a particular student in a subject or across subjects. However, the mean may not always be the best measure of central tendency when data are skewed and the distribution is affected by extreme scores. So when we have extreme scores or outliers in a distribution, usually it affects the values of the mean. So what an outlier does is to pull the values towards itself. So if we have a value that is so small when compared to others, the mean we're going to have as a result will move closer away from others and make it a bit smaller. Not as small as the extreme value itself, but will draw the mean lower, unlike when the extreme score is not there. Similarly, when it's as high as when it's an extreme score that is higher than others, then the mean value tends to be higher when it is assumed that the extreme score is also not part of the distribution. So these are examples or ways by which we can compute the mean if you are given a raw data that you don't necessarily have to represent in a frequency distribution table. We want to move on and give example of how we can compute the measure of central tendency if they are given a frequency distribution table. And we are going to use our previous data that we created for an ungrouped frequency distribution. We created a frequency the raw data was given to us. We created a frequency distribution table, and from that table, we want to determine the mean, median, and mode. In our previous lectures, we look at the example of computing measure of central tendency given frequency distribution table. And to our right here, to our left, we have this table that we created. But this table that was created for books borrowed and number of times borrowed will be the two columns that is needed. So that was extracted, and we have the table towards our right. So we're going to be working with this table towards our right. So the first one we'll determine is mode to determine central score from the distribution table. So how do we use mode? The interesting thing here is that to determine mode, what is important is the number of occurrence. You agree with me that when we created this table, these are the books borrowed. Books borrowed, none of them, the 4 of them did not borrow any book, while 6 of them borrowed 1 book. 5 of them borrowed 2 books. 3 books was borrowed by 3, while 4 books were borrowed by 2 of them. So we have to determine the mode. Mode here, all we need to do is to go to the frequency column and look for the highest number. The highest number is 6. 6 is not our mode. We have to trace it to the X, which is the book borrowed, and the book borrowed here is 1. So our answer will be the mode is 1. That should be the mode. The mode is 1 because it has the highest frequency of 6. Pardon my mistake, that should be a mode, not modes. So we have a mode of what? 1. And the reason is that because it has the highest frequency of 6. That is for mode. Using the median to determine the central score from the distribution table. How do we use the median? To use the median, what we need to do is that the table is already presented in a chronological order. It has been arranged from the smallest to the highest. with their respective frequency, number of occurrences by their side. So we don't have to arrange again. That's one of the benefits of using a frequency distribution table. Since it is like that, then we determine if the score is even or odd. How do we determine if the score is even or odd? So we go to the sum of f, which is 20. Since it is 20, that's an even score. Then we have to identify the positions in the middle. The positions in the middle is the 10th and the 11th. So looking at this had led us to the introduction of cumulative frequency. So looking at the cumulative frequency, you agree with me that the first, second, third, and the fourth position belongs to 0, while the 5th, 6th, 7th, 8th, 9th, and the 10th position, it is 1 that occupies that. So up to 10th, we have 1. So the one we need, the 10th position is 1, while the 11th position starts with what? With 2. So what we need is the 10th position, which is 1. The score there is 1, and the 11th position, which is also 2. This led us to what we have here, which is 1 plus 2. Since it's even, we have to add these two scores together, then divide by 2. So we are saying that 3 divided by 2, which is equal to 1.5. Meaning, we are asked, how often do children borrow books in this school? They borrow a book on the average of, if you have to say using the median, then it is 1.5. Checking the rate at which books is borrowed. So this particular 1.5 represents a central score for books borrowed. They borrowed more than one book per week, but not up to 2. The one we look at is using mean to determine the central score from the distribution table. So using the mean to determine the central score from the distribution table, there is a formula which I did say. There are two formulas given to us earlier. The formula that is uniquely needed here will be the sum of fx divided by sum of f, where the sum of fx is equals to 33, while the sum of f is equals to 20. Then the mean here will be, we have been able to get the fx here, meaning that we have the x, which you already know. We have been seeing that, and f, which we extracted. The next thing to do is to create a column. We call it fx. What we need to do here is to multiply the respective line belonging to f, which is 4 times 0, which will give us 0, 6 times 1, which will give us 6, 5 times 2 will give us 10, 3 times 3 will give us 9, 2 times 4 will give us 8. So if we add this all together, this will give us 33. This will give us sum of fx, which is what we have here, while the sum of f, which we know already, is 20. So the mean then will be 33 divided by 20. This will give us 1.65. This will give us 1.65. So you will recall, you agree with me that if you determine to use the mode as the means of getting the number at the center, the mode tells us that what the most borrowed book is just 1. They borrow 1 book, which is the mode. That was what the mode gave us. For the median, it is 1.5, while if we use the mean, it is 1.65. All right, following this experience in this class, I will just so that we can also try them on our own. So find the mode, median, and mean of the following distributions. Ready for this particular slide too. So having looked at this, we want to quickly look at measure of dispersion. While measure of central tendency talks about getting the number at the center, a measure of dispersion, which is also referred to as measure of variability or measure of spread, it shows the homogeneity or the heterogeneity of the distribution. That is the extent to which the numbers are squeezed together or they are stretched. So given a set of numbers, how well are they revolving around the center? Are they scattered around the center, or they are very close to the number at the center? So particularly, we look at 3 types of determining that. We have the range, we have variance, and standard deviation will be our focus for the class. How do we determine the range? The range is defined as the difference between the largest and the smallest value in a distribution. So meaning that range is equal to the highest number minus the lowest number. So one of the simplest measure of variability, it is one of the simplest measure of variability, and it is only done or computed using the extreme values. So it doesn't provide information about the rest of the data in a distribution. We only look at extreme values. We'll look at an example, but let's quickly look at what The variance is the average of the square difference from the mean. The average of the square difference from the mean. The average is the square difference is the average of the square difference from the mean. The variance in statistics is the measure of spread between numbers in a data set. Variance is the measure of spread between numbers in a data set. That is, it measures how far numbers in a set is from the mean and therefore from one another in the data set in a set. So how do we compute the mean? It is about sum, open brackets, the score minus the mean. After getting that, we have to square it. Then we divide by n minus 1. Well, that division, which is the square root of the sample of the variance, is the square root of the variance. The standard deviation is the positive square root of the arithmetic mean of the square of the deviations from the given values from the arithmetic mean. So when we have our variance, all we need to do is to find the square root formula we have here. The formula we have inside the square root is the same as that of the variance, meaning when you must compute your variance first. After computing your variance, then you find the square root of that will give us the standard deviation. So let's look at an example. Analyze our explanation of the measure of dispersion. So given this, the following data give the weight loss in pounds by a sample of 5 members of a health club at the end of 2 months of membership. 10, 5, 19, 8, 3. Compute range, variance, and standard deviation. So from here, the range is just first introduced to identify the extreme score. The highest score here is 9, while the lowest score is 3. So 19 minus 3 will be equals to 16. 19 minus 3 equals to 16. So the range here is 16. Variance, first we need to compute the mean of the distribution for us to get the variance. So since there is a mean that is also a part of the computation of the variance, we must identify the mean first. So to identify the mean here, we sum the x divided by n. Sum of x divided by n is more appropriate here than sum of fx. So we have to sum all the numbers. By summing them all the numbers, which is 19 plus 10 plus 8 plus 5 plus 3, then divided by 5. That gives us 45 divided by 5, that's 9. So the next thing to do is to say, since this is the x, this will be x minus the x bar, which is the mean. 19 minus 9, which is 10. 10 minus 9, which is 1. 8 minus 9, which is minus 1. 5 minus 9, which is minus 4. And 3 minus 9, which is minus 6. The next thing is to square the answer we get here. We square it, meaning 10 times 10 will give us 100. 1 times 1 is 1. Minus 1 times minus 1 will give us 1. Minus 4 times minus 4 will give us 16. Minus 6 times minus 6 will give us 36. By the time we sum all this together, it gives us 154. So instead of writing summation, open bracket, x minus x bar squared, write 154 there. Then n is 5. There are 5 scores in the distribution. Minus 1, that gives us this 4 here. That's 154 divided by 4. That will give us 38.5. That gives us 38.5. So our variance will be 38.5. We want to look at is the standard deviation. And the standard deviation, we said, is the square root of the variance. And the answer we got for the variance was 38.5. So all we need to do is to find the square root of 38.5, which gives us 6.25. All right, I hope we have been able to follow the class through and also appreciate and also understand the meaning of whenever we hear measure of central tendency, its meaning and what we mean by measure of dispersion. Okay, and I will urge you to look at this, and during our next meeting we can also discuss further about areas that you think that are not so clear. But for the meantime, I wish you best of luck. We end the class here. Bye, everybody.